Maclaurin series. Some mathematical functions can be represented as a power series containing terms in ascending powers of the variables. For example, e power of x, sine x, and hyperbolic cos of x, cos x, are given in the functions here. Using a series which is known as the Maclaurin series, the mixed functions here can be expressed solely as the algebraic functions, and differentiations and integrations can often easily be performed. Let us look at some examples of the Maclaurin theorems. Given a power series of xx here, which you can actually differentiate the power series levels by levels, and when you substitute x is equals to 0 into all the power series which you have derived earlier on, you will get this. You will observe there is a patterns in terms of the sequence within the series, especially when you look at the third order of differentiations. The 2 here represent 2 factorial. 6 here represents 6 factorials. Having this as an equations, the A2 here will be moving the 2 factorials to the opposite side, which will give you this. Same goes to this. 3 factorials is being moved to the other side, you will get this. Based on the pattern here, you are able to predict the following. Your A4 and A5, it will be the 4th level of differentiations divided by 4 factorials and 5 factorials for the 5th levels of differentiations. Now, if you substitute all the A value here into the power series here, you will get this. Rearrange these solutions, you will get this as the formulas of the Maclaurin theorems. Let us try an example on these Maclaurin theorems. You are asked to find the first 4 terms of the power series of cos x. The first 4 terms means the first 4 terms of the series here. In order to acquire the first 4 terms, you will need to refer to the formulas of the Maclaurin theorems, which is written in this manner. From the formula here, there will be differentiations at various levels. In this case, let us try to the level 6 differentiations. Given fx is equals to the cos x, differentiating this gives you negative sine x. Differentiating it, you get negative cos s, and so on and so forth. Now you have a list of the differentiation here. Substitute 0 into the list of the functions here, which will give you 1, 0, negative 1, 0, 1, 0, negative 1. Substitute the relevant value into the functions here. Whichever to be multiplied with 0 will be cancelled out, and the rest will remain. Take note of the positive and negative value. Solve this function here, you will get the series here. This will represent the 4th term. The questions asks us to find the first 4 terms. Normally, before the solutions, or before we come up with the solution here, we are unsure to which level we need to differentiate. What you can do here is you can differentiate levels by levels. When you observe the 0 here, That means this is not going to contribute to any term in the series. With that, you are looking at first, second, third and fourth term. Therefore, you know that you have to differentiate until to the level 6.